Hello everyone, I'm Srijan Das. Today I will be presenting ViewCLR, Learning Self-supervised Video Representation for Unseen Viewpoints. This is a work with Mike and Rio at Stony Brook University. In this work, we address that challenge of video recognition models that fail to generalize over different camera viewpoints. We also realize the fact that computer vision has been shifting from supervised to self-supervised paradigms. However, these SSN, like contrastive learning, are not fabricated to encode viewpoint invariance. So we introduce ViewCLR that aims at learning video representation that generalize across different viewpoints. Let's talk about a popular self-supervised approach, MoCo. In this method, similar pair of samples are generated by the use of two different set of augmentations. Then a contrastive loss maximizes these sample pairs and minimizes the similarity to negatives, which are the other samples in a batch. Towards our goal, we can pursue these naive approaches. Use a strong augmentation that generates a different viewpoint for a given video sample, but these approaches are not scalable. Introduce a viewpoint generator in the manifold space of the EMA, but copying the weights from the encoder will result in inconsistent weights at the EMA. So our method is a spiritual adaptation of neuron projection layer, which is designed for supervised settings. In this work, we introduce a viewpoint generator based on NPN. At first, 3D space coordinates are estimated from the input feature map. Then the intrinsic camera parameters are estimated. These camera parameters, along with 3D space coordinates, projects the 2D feature map to 3D space. Again, a camera matrix is known to reproject the one feature map back to 2D space. In order to make NPN work, a 3D constraint is imposed between the word representation of two videos pertaining to the same action category. However, in this case, we do not have access to any neighbors. And that's why the question remains, how do we use this viewpoint generator in a self-supervised scenario? So what we have is a MoCo framework, and the idea is to use a viewpoint generator in this framework to learn viewpoint invariant video representation. Therefore, we have introduced viewpoint generator in a new third stream. How do we introduce these novel latent viewpoints? Through mix-up augmentation strategy. Here we perform a manifold mix-up between the output feature of the viewpoint generator and the intermediate feature map of the encoder. We fabricate the 3D loss of NPN in a self-supervised setting. We introduce a new dictionary queue to store the 3D latent features. We make a hypothesis that nearest neighbor of X in Q1 belongs to the same category as X. The index from the previous step is used to retrieve the corresponding 3D latent viewpoint representation of X in Q2 to compute the 3D loss. We use adversarial learning to generate unique viewpoints while reprojection from one features to 2D features. Here we present the abnation study to show the effectiveness of each component in ViewCLR. Our representative baseline is a MoCo model trained with InfoNCE loss. Here we present the state-of-the-art comparison of ViewCLR with other methods. The most consistent model on these dataset is VPN, which is pre-trained on kinetics and use RGB and post modalities. ViewCLR outperforms all of them. Thank you.